Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x to the power of 2023 is equal to 2023. And I actually have two methods to solving this problem. So the first method is, well, we start by having x to the power of x to the power of 2023 is equal to 2023. Now I'm going to set x to the power of 2023 equal to the variable y. So if this is true, then I would have now if I take the power of 1 over 2023 on both sides, I get x to the power of 2023 to the power of 1 over 2023 is equal to y to the power of 1 over 2023. Then if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So now x to the power of 2023 to the power of 1 over 2023, that's going to equal, well, in this case, a is equal to x, m is equal to 2023, and n, this is equal to 1 over 2023. So I would have a to the power of m times n. So x to the power of 2023 times 1 over 2023. Now, 1 over 2023 is the reciprocal of 2023, and reciprocals, they obviously cancel out. So 2023 divided by 2023 is obviously 1. So then I am left with x to the power of 1 is equal to y to the power of 1 over 2023. Now, x to the power of 1 is the same thing as x, so I have x is equal to y to the power of 1 over 2023. All right, so now that we have our value for x, well, remember how our original equation was x to the power of x to the power of x to the power of 2023 is equal to 2023. And remember how we set y is equal to x to the power of 2023. So now if y is equal to x to the power of 2023, then we have x to the power of 2023 right here. So I'm going to replace that with y. So now I have x to the power of y is equal to 2023. Now remember, this is equal to y to the power of 1 over 2023. So if this is true, now I can replace x with y to the power of 1 over 2023, and then I have this to the power of y, which is equal to 2023. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, right? And a to the power of m times n, these two are interchangeable, meaning this would also equal a to the power of n times m, because for multiplication, order doesn't matter. Meaning, a to the power of m to the power of n, this would equal a to the power of n to the power of m. So you can switch the order of the two. So in this case, for y to the power of 1 over 2023 to the power of y, I'll switch the order. So now I have y to the power of y to the power of 1 over 2023, and this is equal to 2023. Now what I'm going to do is I'm going to take the power of 2023 on both sides. So I have y to the power of y to the power of 1 over 2023 to the power of 2023 is equal to 2023 to the power of 2023. Now remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this would equal y to the power of y to the power of 1 over 2023 times 2023. And this is equal to 2023 to the power of 2023. So then these two would cancel out. So then I would be left with y to the power of y is equal to 2023 to the power of 2023. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b as long as b is greater than or equal to 1, which in this case, b is 2023, which is greater than or equal to 1, meaning y is equal to 2023. However, we are not done yet because y isn't what we're solving for, we are solving for x. And remember, we set y equal to x to the power of 2023. So if y is equal to x to the power of 2023, and if y is equal to 2023, then I have 2023 is equal to x to the power of 2023. Now I can take the power of 1 over 2023 on both sides. So now I have 2023 to the power of 1 over 2023 is equal to x to the power of 2023 to the power of 1 over 2023. So then these two cancel out, and I would be left with 2023 to the power of 1 over 2023 is equal to x. Now I have a second method to solve this problem. So my second method is, well, remember our original equation was x to the power of x to the power of 2023 is equal to 2023. Now, if x to the power of x to the power of 2023 is equal to 2023, and, well, we have a 2023 right here, right? So if 2023 is equal to x to the power of x to the power of 2023, then this is the same thing as x to the power of x, and then 2023, well, this is equal to x to the power of x to the power of 2023. So then I have x to the power of x to 2023. And then I would have to replace 2023 again with x to the power of x to the power of 2023. So this would actually be infinite, infinitely going on and on and on. So if it infinitely goes on and on, then I can just set this as x to the power of 2023 is equal to 2023. And I can set all these x's as simply just x. So now if this is true, I can now simply take the power of 1 over 2023 on both sides. These two will cancel out, and I'm left with x is equal to 2023 to the power of 1 over 2023. So this is a much simpler and faster solution to solving this problem. Hey guys, welcome back to Click Academics. In today's video, I'm going to be going over a nice algebraic equation. So right here we have our equation x to the power of 6 equals x minus 1 to the power of 6. And if you notice, you can see that both sides of the equation are to the power of 6. So to simplify this equation, why don't we find the sixth root of both sides? So then we can make it much simpler. So x to the power of 6, we're going to do x to the power of 6 to the sixth root. And this is going to equal the sixth root of x minus 1 to the power of 6. And these two actually cancel out. So x to the power of 6 to the 6th root, it's going to cancel out because these two are opposites. So remember, opposites cancel out. So this is simply going to result in x equals, these two are going to cancel out as well. So we're just left with plus or minus, remember, we got the plus or minus x minus 1. So now this gives us two equations. This gives us x equals positive x minus 1, or this gives us x equals negative x minus 1. Let's first try the positive. So we're going to do x equals x minus 1. It's just, and now if we subtract x on both sides for this, we get 0 equals negative 1. And this is actually a false equation, meaning this wouldn't work. X can't equal x minus 1. So we can't use the positive version. So now let's try the negative version. Let's do x equals negative 1. It's the same thing as just negative x minus 1. So now we're going to have to distribute this negative 1. So we're going to multiply with x and negative 1. So this results in x equals negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And now we're going to add x on both sides. And x plus x is 2x equals 1. And now to isolate x, we're going to divide by 2 on both sides. These two cancel out. So we're simply left with x equals 1/2. And this is our answer to this equation. Now let's check to see if it works. Why don't we plug in 1/2 into our equation here? So this is going to be 1/2 to the power of 6 equals 1/2 minus 1 to the power of 6. Well, 1/2 to the power of 6, that's going to be 1/64. And this equals, well, 1/2 minus 1 is simply negative 1/2. And negative 1/2 to the power of 6, well, that's the same thing as 1/2 to the power of 6, because even if you square a positive or negative number, as long as our exponent here is even, then our answer is always going to be positive. And since our exponent here is even, then our answer here is going to be positive. So negative 1/2 to the power of 6 is also 1/64. So this is right, meaning x does equal 1/2. So this is our answer to this equation.